Video, we will look at the free radical polymerization of methyl methacrylate. The first step in those mechanisms is the dissociation step. So for this example, we take benzyl peroxide, this molecule, what will yield the radicals at elevated temperatures. So what will happen with this peroxide is that this bond will undergo a homolytical cleavage, and if we draw the Lewis structures, this bond, here an electron and here an electron, will split evenly. So one electron will go there and one electron will go there. So look at the half-headed arrows, because that's we use that for radicals. So what will yield this? This will yield two radicals, Lewis structures. So a radical times 2, because we have 2 steps. Okay, in this example it takes another step to yield the radical, and here this bond is very weak. It can undergo decarboxylation, and here this bond is broken, so here will form a new radical. Here will go, and this electron will go there, so here's a new bond formed. So we will get at the end a stable radical stabilized by the structure, and the decarboxylation takes place, what will yield some CO2. So this is our species what we'll use in the initiation step. So before we going to look at the attack of the radical to the monomer, we first draw the monomer. The monomer we use in this example is methyl methacrylate. It looks like this. Actually, this is not a quite convenient structure to draw for polymer mechanisms, so we convert it a little bit for our convenience. We do it like this. We draw it a little bit expanded, but at the time we will abbreviate it, because this group, the rest group, is R. We will draw it as R, so because we don't want to draw it every time, because we have to draw a lot. So this is actually the part what will take plays a role in the mechanism, because this is the functional group what is reactive with the radical. And exactly we draw it like this because we take into account the stabilization, so we can draw it very easy. Okay, the initiation step. So we take the radical we have formed in at the dissociation step plus the monomer. And this is R. And so, by the way, when you draw your mechanisms, please write it like this. So the double bound aligned horizontally, and the rest group, the R group, pointed downwards at the right side of the polymer, of the monomer. So we see it in the next step, the most stable position. Okay, back to the initiation mechanism. Here's the initiator, so the free radical, and here we have the monomer. So once as the same in the initiation step, we draw half-headed arrows. So here are 2 electrons. This will form a new double bound, and here we get a new radical. So the first monomer, what we will find is this, or the first structure, R, and the new radical. So this is the initiation step. Okay. After the initiation, we go to the propagation. And we know that if we have initiated a reaction, a lot more monomers will react. So we already draw here a polymeric structure, and we draw here the chain end, the free radical chain end. So again, we take a new monomer, CH3R, and exactly the same as in the initiation, but we have another radical. We do it like this, half-headed arrows, and that will yield a propagating chain. So, and this, of course, will go on until the termination. Note here the +1 because we added a new monomer. And n is of course the polymerization degree. So the longer we go, the bigger this number is. And here of course the free radical end, of course. That's the propagation. At the end we get the termination. And we will divide the termination in a few steps, in 3 steps. The most convenient, simplest one is termination by combination. And here we draw 2 active polymeric chains. And first we draw what we get in the propagation step, H, and we draw a second one, but we flip this one because that's more convenient in our mechanism. So it's a lot of drawing, you see. So practice a lot because it's quite. Otherwise, it takes a lot of time. So, okay, and here those 2 radicals will combine to a new polymer, and we will yield, of course, so we will yield a dead polymer. So now it's terminated. Of course, I have to put here an M. What is very important to know that in this mechanism, the molecular weight is doubled or is higher than the separated polymeric chains. What will take into account in the mechanism. So look at the doubling of the molecular weight. CH, H, and here M, and the initiator. And so look at the new covalent bound. Yes, so that's the first one by combination. The second one is a little bit more difficult. It's termination by disproportionation. What will it mean? So we take again the polymeric chain, CH3R, and in this example we also flip the polymer for the convenience in the drawing. So let me finish this. It's a little bit boring, but get used to it. And practice a lot, of course. So what will happen in here is that those 2 radicals will not be combined, but this proton here and this bond, of course, will also will take place, will play a role in the mechanism. So what we will see is that this bond and this radical, so these are 2 radicals of 2 electrons, one of this will go here and this radical will go here, so we form here a new bond, a double bond, and this electron with the proton, so the H, will go to this one, like this, and we form here a new covalent bond with the H. What will yield that? And that's a little bit, so I will abbreviate it now a little bit, because otherwise it's taking too long. But we have this one, H double bound CH3R, so this is a new very strange structure. Now, we don't expect any polymerization, but it takes place. And here we get the polymeric chain, etc. So taken into, very important for your exam, you just draw here this structure, of course. This structure. So not doing like this, what I'm doing, but for this movie, it takes too long. Okay, and the last step, this chain transfer. Chain transfer. We will look at that in some lectures later. And we add a chain transfer agent. So in this case, we still have the same polymer, but we will add CH3R, add a chain transfer agent. And the char accent SH. So this is an example of a mercaptan. And this is a quite weak bond. So this H will react here. So what we will see is that like this here and then here and this one. So it is there and this goes there. So it will yield a dead polymer. CH, CH3, NH, CH3, and here we get the H of here, the proton, plus RS radical. And this can initiate a reaction again. So actually we don't, it doesn't influence the reaction speed at all, but only the chains will be shortened a little bit. So the molecular weight will be not that high if we don't use the chain transfer agent. Okay.